Why is Redis fast? And I know you have got an answer because everybody has the same one. And the answer is it is in memory. But if that's the whole reason, something should bother you here because Memcached is in memory too. And so is the hash map inside your own service right now. So let me show you where a Redis request actually spent its time because it is not where you think. So let's start with where everybody stands, because this part is genuinely strange. Postgres starts a whole new process for every client that connects. Nginx runs one loop per worker. Node runs one loop for an entire app. And Redis runs a single thread. And out of all those four, it's the fastest. So one thread is waiting a process per connection, which means this was never about memory. So here is Mida. She is opening a shopping app and she taps product 8821. Your service needs the price, so it fires one command at Redis and answered it back in about a quarter of millisecond. That is a number everyone quotes. But almost nobody asks where the quarter of millisecond actually went. So let's break it open because it splits into two very unequal halves. Redis, which does the actual work, which is finding the key, reading the value, building the reply. It takes less than 1 microsecond, and a microsecond is a millionth of second. Then there's the trip out to the Redis box and back, which is called a round trip, and an ordinary 1 gigabit network that costs around 200 microseconds. So sit with that for a second. Because for every microsecond Redis spends on your data, the trip spends more than 200. And Redis is not the slow part of the Redis request. It's not even close. And that's not a lab number because when Stack Overflow published their real production figures, the round trip was 0.17 milliseconds out of 0.2 to 0.5 in total. And if you don't believe the split, just delete the network and watch. Instead of sending one command and waiting, you send 10,000 at once and read the replies at the end. This is nothing but pipelining. So same Redis, same box, and the throughput goes up to 10 times because you stop paying for the trip. So Redis on documentation benchmark it where they tried it on MacBook Air and they were able to achieve 500,000 writes a second. So the real question was never why Redis is fast, because Redis barely does anything. The real question is why everything else is slower. And the answer is that everything else promised you something extra that Redis never did. So picture a ladder. Every step up, you get one more promise kept. And every promise costs you time. Redis sits near the bottom and that's the whole trick. So let's start at the bottom step. And I'll be honest, this one is a bit uncomfortable. If you keep Mida's price in a plain hash map inside your own application, that lookup is around 50 nanoseconds. And that never touches the network. That is about 1,000 times faster than Redis. So why use Redis at all? Because the map is gone the moment your app restarts and the server next to it cannot see it. So you are not paying for speed. You are paying so everybody reads the same copy. So let's just climb up the ladder and see who is sitting next to Redis. It is Memcached. And this one should have killed this in-memory answer years ago. Memcached keeps everything in memory exactly like Redis does. And on plain gates and sets, the two run at about same speed. Redis says so in its own documentation and calls the difference not that big. So memory cannot be the answer because the thing right next to Redis has the same memory but still it doesn't win. So let's go one step up to Postgres because that's where Mida price really lives. You don't hand Postgres a key, you hand it a sentence in a SQL. So before it can get anything, it has to read the sentence, work out which table you meant, and then figure out the fastest way to find your row. The last part has a name, the query planner, and it is smart. Smart just takes time. And Redis doesn't have one because Redis never let you ask a question big enough to need it. And that was just a read. Now watch what happens when Mira actually writes something. Because a write has to end up somewhere permanent. So Postgres writes an order down, okay? And then it waits. It asks the disk, are you sure you have got this? And it will not tell Mira the order is saved until the disk says yes. That question has a name. It is called epsync. And that waiting, not the query, is where most of the write time goes. Now let's see what actually happens when Mira hits a buy. Her order has to end up on a disk, right? So Postgres won't tell her it worked until the disk says yes. So the wait is slow. But if the power dies a second later, her order is still there. And Redis does the opposite. It tells her it worked straight away and writes to the disk a moment later. It is faster for sure. But if the power dies right then, her order is gone. And that's not a built-in feature. It is a setting. And you can flip that setting on either of Postgres and Redis. Now come to the step above that, where the things like etcd and dynamodb live. Because they don't write to one disk. Say there are like 3 machines. All 3 get the order. And at least 2 have to say yes before you hear anything back. That's called a quorum. And you already know what that costs, right? A trip across a network and a disk saying it's done. Except now this is happening on 3 machines instead of 1. So there is one honest note that we should add. This ladder is not a ranking. Nobody runs a bank just with Redis, right? So let's turn the whole thing around, because then it gets really simple. Redis sits at the bottom of the ladder because of everything it said no to. No waiting for the disk before it answers you. No transactions, no joins, and no planner to run them. No using more than one CPU core, and no promise that a second copy has caught up yet. And every single one of those is something that you might actually need, which is why Redis sits next to your database, not instead of it. Okay, so if Redis barely does any work, how does one single thread keep up with thousands of people at once? Well, look at how a normal server does it first. It gives every connection its own worker. That worker asks the connection for data, but the data hasn't arrived over the network yet. So the worker just sits there and can't do anything else. Do that 20 times. And now we have got 20 workers sitting perfectly still. And sitting still like that is what we call blocking. Redis refuses to do that. It doesn't give a worker to every connection, and it doesn't stand there watching them either. Instead, it takes every connection that is open and hands the whole list to the operating system in one go and says, don't wake me up until one of these has something for me. So somebody is still watching. It's just that it's not Redis anymore. And that handover you just watched has a name. It's called epoll. So epoll is operating system tapping Redis on the shoulder when something is ready. Instead of Redis walking around and asking every connection whether it's got anything. It's the difference between checking your phone every 10 seconds and just letting it budge. So what does that one thread actually do all the day? It runs a loop, and it's a really short one. It asks the operating system, is anything ready? Then for whatever is ready, it reads the request, runs the command, and sends the answer back. Then it goes around, asks again. That's it. This is the whole of Redis. Now hang on. Because if it is going round and round like that, surely it is running a whole CPU doing nothing, right? And that is an obvious question. But the answer here is no. When nothing is ready, Redis is not going around at all. It stops on the very first question, is anything ready? And while it waits there, it uses zero CPU. The operating system wakes it up whenever something arrives. So Redis never has to check. Is this one thing that falls out of having a single thread, and that matters more than the speed does. So when the loop picks up a command, it finishes it completely before it even looks for the next one. So two commands can never touch your data at the same moment, and this is called atomic. And it is why 1,000 of people can tap Mira's product at the same time and all adding one to the same view counter. And you still don't need a lock or a transaction to keep it safe. So why doesn't Postgres just do all of this? Like, it could have used a single loop or a thread, right? The thing is that loop only works as long as every job on it is small, because it does them one at a time. So one slow job and everybody behind it keep waiting, right? So a Redis command takes less than a microsecond. So nobody notices that, right? But a Postgres, a query can actually join, like, let's say 10 million records, and it will end up taking 8 seconds. So on a single loop, that one query would reach every other person using your site. So Postgres pays for all those extra processes to protect itself from all other slow queries. So actually you can cause the same exact problem, this freeze problem yourself with just one command. So let's say your shop has got like million keys in Redis, right? So most of the command would just touch one of the keys. That's why they finish instantly. But the command keys, it looks at all million before it answers. Now Redis does one thing at a time. So it has to work through all those million data, and while it does that, every other customer has to wait. So Redis on guide says that don't run keys in production, use scan instead, because it does the same job 1,000 keys at a time, and at the same time it let everybody else in between. There's a second one, and it is not even the command you run. So when Redis saves your data on a disk, it split itself in two, and that is called a fork. And to do it, the operating system has to copy the map of where all your memory lives. So on a 24 gigabyte server, the map alone is 48 megabytes. So Redis documentation says copying it can stop the server answering anyone for milliseconds, or it can go up to seconds at time. So if let's say Redis was working fine all day and it randomly hiccups, now you know the answer. And I'd like to do a one honest correction before somebody just start putting it in comment. So modern Redis does use other threads, but these are the background ones. It is for like slow jobs, writing to the disk, cleaning up big values, and those have been there for years. And since version 6, you can turn on these extra threads for reading and writing the network. But they are of useless until you ask for them. So your commands still run on that one single loop and one at a time. And that cuts both ways, as we know now. No logs, but one slow keys and everyone waits. So does any of this actually hold up in production? Let's take Stack Overflow. They publish their numbers, and at their BGS, Redis was handling almost 87,000 commands every second. Now here is the part that matters. The average CPU on those servers was 2%. 2%. That is a machine doing almost nothing. And it was at the same time serving the cache of one of the most richest sites in the internet. And they said it themselves that they were nowhere near any memory limit. And Redis didn't invent any of this, which is worth knowing because Nginx runs the same loop in every worker. And Node, they actually built a whole platform on top of it. So anytime somebody is saying non-blocking to you, this is the loop that they are talking about. So next time somebody asks you why Redis is fast, don't stop at it's in memory, because the real answer is that Redis is fast because it refuses to pay for things. And that's the part you can steal. So next time something of yours is slow, the question is not how do I make this faster? It is what is this paying for, and did I ever agree to buy it?